So, I mean, it's no secret that how AI, cloud, connectivity are all transforming the way we work, the way we live, and it's all driven by data, right? It's all data-driven, everything. And the underlying infrastructure that is very critical that enables all of these AI, cloud, whatever we do, whatever we work, is the data center. Now, when I said this like this, it sounds like very simple 2 words, but I think the gentlemen here on the stage know what it takes to design and construct the data center, not only to meet the requirements of their particular clients, thank you, but also to make sure that it is built fast enough to keep up with the speed of the demand. It is built in a cost-efficient manner and from environmentally sustainable manner. Yeah. So today's discussion or today's point of discussion is what does it take to basically design these data centers from designing construction, and how the overall ecosystem, whether it's from the technical design perspective or vendors construction perspective, how are you guys meeting the or how are you guys keeping the pace with the exploding demand, both in KSA and the overall region? So can I ask you to introduce yourself quickly, and then we can get into the questions? Yousef, go ahead.
Thank you, Samir. Myself, Yousef Maayah. I'm the Vice President for the GCC from Sudlows Consulting. At Sudlows Consulting, we are a specialized data center with a turnkey solution of services, including the design, the supervision, testing and commissioning, visibility, and facility management.
Thank you, Yousef. Neuenfeld from Townsend. We are here for project management, cost management, schedule management, owner services. So we do PMC roles across the kingdom and in the Middle East. I think we are the biggest organization for these services. We have at the moment 40 full-time employees in country and 1,000 in especially for the data center, and 1,000 in the Middle East consultants.
Yeah, good afternoon, everyone. Thanks for joining us. My name's Alistair Davis. I work for a company called Black and White Engineering. We're a specific data center engineering company with about 1,000 staff across EMEA and APAC. I've been in the Middle East for the last 18 years, and I lead the Black and White Middle East team.
Assalamu alaikum. So first of all, I don't think I resemble my picture out there. That's not an AI reincarnation or avatar, but that's me 6 months ago. So first of all, thank you all for being here, and thanks to the organizers for this wonderful event. I think a lot of our colleagues are still at lunch, so maybe if you can gather them around, that'd be great. So I specialize in design and build side of data centers. So I own a construction company in Dubai and a development company as well. My business partner is here. And we develop a lot of infrastructure work across Middle East and South Asia as well. Today I will definitely, if given the chance, I'll speak about the funding challenges that are a key success factor for data centers. Thank you.
Assalamu alaikum. This is Mohie, electrical manager in Data Engineering. We're a design consultant for data center, for healthcare, different actually sector in the kingdom and even outside the kingdom. It's really my pleasure having me in this event and of course in this panel discussion with the gentlemen.
Great. So let's start the discussion, and I'll start with the very fundamental question. So we all know how data center demand in the kingdom is evolving and is forecasted to grow from 100 odd megawatt right now to up to 1 or more than 1 gigawatt in next 3 to 4 years. Yeah. So the first question that comes to everybody's mind is, what are the most critical design and engineering innovations that are needed to meet this unprecedented demand in the kingdom? So if I may ask Jan to start with that, and obviously everybody can contribute to the question, but Jan?
Yeah, I think the most critical thing is PoE, the PoE challenge here in the region. The data centers what are built here between 1.6, maybe go down to 1.4 PoE. When you look for the Google Fleet standard, what you find in the internet, they are 1.05 over their fleet. So this is a big disadvantage here for the region. And to attract the hyperscaler or all this AI learning demand and all demand what is not really generated in the country, we have to look at the PoE to get the data centers more cost efficiency, to reduce operation cost, that they decide to build the capacity here and not somewhere in Europe or in the Nordics, where the cooling solutions are much more cost efficient. Even when the power price here is less, but to secure a 40-50% gap and the lack of renewable energy at the moment. I know Saudi Arabia is building a lot in this direction, but Google announced from 2026 they are 100% on renewable. So this is for me the two main challenge here in the region for the design for the next years. And then on the other side, you have the big capacity announcement. Humain announced last week that they will build 1.9 gigawatt by end of 2030 and 3 gigawatts or 3 to 6, depends which source, by 2034. And there are other big companies what have every also gigawatt announcement in the KSA when everything is coming up and will be built. Then we have by 2030 here 3 to 4 gigawatt.
Sure. And you see a lot of initiatives happening from the in the overall ecosystem to find out solutions to reduce this PUE, because there is obviously the fundamental challenge about the weather, right? That you can do as much on PUE. So do you see a lot of initiatives happening, a lot of innovations happening in this space?
Slowly it starts. You have to increase the temperature in the data center, that you go back to a natural cooling, what you have in the Nordics. Mm-hmm. When you manage this, then the PUE challenge is gone. When we increase the temperatures in the data center from around 20 degrees, let's say, to 30, 35 degrees, that we come closer to a natural cooling, then we don't need the chiller or this additional cooling solutions anymore, because we can go back to natural cooling towers.
Understood. Mohamed, you wanted to contribute to this?
Actually, the power load density is a very crucial parameter here in designing the AI data center. So even traditional data center now is not anymore capable to cater the new requirements of the AI. So to handle this, actually, we need to have a holistic data center design, from upstream network to downstream network, from the tie-in points from the utility service provider till the IT equipment inside the computer room and the rack itself. So by considering scalable and modular and flexible data center design from architectural perspective, by considering and reserve MEP spaces to cater the new requirements in future, and also with respect to the selection of the electrical equipment from the US, from the BDU, it should be scalable and modular to cater the new requirements. So by considering this one, you will ensure that you have a future proof data center which can cater the new requirements of AI.
Sure. So if you want to go ahead in.
I think, I will support Ian in his point, because in order to drop the PUE value, basically, it's more about the load of the mechanical system, mainly the chiller. How you can drop that is by delta T. If you are able, and this is now possible and achievable, even recommended for the AI, to have high temperature in the white space, 35 as supply, returning, let's say, early 40. What this basically allow you is to be more able to utilize the free cooling, changing your design to more cooling tower system. Additionally, this will also help you with reducing the size of your chillers, your chilled water pumping system. By doing that, obviously, because end of the day, the IT load for you more or less is the same, you get somewhere around the 1.2, 1.3, which is definitely, from sustainability part, is more attracting to hyperscalers.
It will not only reduce the power cost for the customers or the data center providers, but it will also impact the capex as well, right? Because if you are going to build smaller equipment and so on and so forth.
Obviously, because as a capex, you have smaller chiller capacity-wise, smaller mechanical system, so the capex cost is lower, definitely.
Yep, makes sense. So moving on, so first we talked about the design and the construction, engineering innovations. But the other part is about how do the vendors keep up with the pace of the demand, right? So we have seen a lot of modular and prefabricated approach in terms of construction. So I would like to delve deeper into that how are these modular and prefabricated approaches towards the construction helping developers reduce time to market and meet all the standards from tier 3, tier 4 data center perspective. So Yousef, if you want to start on that.
Yes, definitely good question. Modular and prefabricated is not becoming a luxury, it's becoming a necessity, especially considering that more of the current clients are basically looking for earlier to market. Earlier to market means your project need to be fast enough and sufficient with construction. Most of data center are now denser, so you have higher density. So if you look at it, the modular and prefabricated is definitely a solution. The challenge with the traditional data center is basically you are doing linear construction. You need to go through the utilities, you need to go through the substructure, superstructure. It's only when you finish the building, when you start your MEP installation. So any advantages you could achieve earlier by early engineering, by early long lead item procurement, you already lost it as the building is not ready. And then obviously after you finish the MEP, you go to the IT. While when you go to modular solution and the prefabricated, allowing for proper designing and early engineering, you are releasing your order for the long lead item earlier, allowing for early access to site, which means as you doing your utility and your structure, it is in somewhere else in the world where your critical component, your critical solution is being built, and this is just coming to site in the right time to be installed, just purely plug and play. The beauty of the solution is basically all the solution currently with the leading vendor in the market are also allowing you for the scalability and allowing you also to comply with uptime requirement, because those vendors are already in touch with uptime when it comes to having the product, the solution itself, as tier certified, being tier 3 or tier 4. So this is one part of it. The other advantage of the modular solution is coming to the installation, because you already produced a product in a factory controlled environment, and that basically allow you to have a higher quality product, fully tested product, and ready whenever needed. Coming back to the scalability part, the advantage of it goes back to the initial engagement with the client when you design it. So you design it in a way where the complete building as a data hall is built, and the modular solution can work around the main building. So if you are looking to scale at, say, year or two from now, you can do that easier. And that's basically take us also touching to the point mentioned by Mr. Khan, which is connected to the fund. Because sometimes you secure the fund for day one and you can secure the fund for the full project. So you do it as stages, day 1, day 2, day 3.
Sure.
And allowing basically everything to go smoothly, clients see it, being able to secure their own customers, etc.
Alistair, you want to contribute to this?
Yeah, thank you. Modular solutions are not solely for the use in data centers. They are used on all types of building solutions, and it's something which works well, is successful. I've worked on many data centers where modular solutions have been incorporated. But when we say modular, there are many grades of modular. So you can go to the very extreme where you can go to certain manufacturers who will actually bring a containerized solution, drop it on a site, and you just provide it the necessary infrastructure, power, telco, this, that, and the other. So you can literally go all the way to that extent. They're limited in size, and there is a cost associated with it. But if you want a quick deployment of IT capacity, it's a perfect solution. You can get up to 1 megawatt, maybe a little bit more, in a solution like that. And then obviously you can, as you talked about then, Yousef, obviously do that at scale and phase it as you require. So that's one scale. Yeah. But modular solution can also just be simple as having skid-mounted equipment. So you might have your chilled water plant room and you build it out in a skid arrangement. So modular design and construction there's a great scale of that, and it's really dependent on what you need as a client. So it might be that you want to have something really quick, which will come at an increased cost, or you might want to taper that slightly and go with a more mixed approach.
Yeah, you want to...
Well, just one point to what my colleague Alistair mentioned. Yes, you might be paying, let's say, 5-10% premium, but in reality, when you are looking at the quality of the final product, the saving you are going to have in the OPEX, and obviously even at the execution time, when you look at the time saved with the labor costs and the prelims, I think it is very efficient from cost perspective too.
No, I would agree. I guess one other thing as well, just to add to that, as it's occurring in a manufactured or in a warehouse, the other thing you get as well is health and safety. It's a very controlled space. We know construction sites can be hazardous. Thank you. That's the exact word I was thinking of. Thank you. Can be hazardous, when people don't follow a certain process. So if you're going to be doing all of this within a clean, safe environment, it massively benefits the health and safety of the whole project.
That makes sense. And just building on that, so you touched upon these standards kind of thing, basically how you ensure that the health and safety guidelines are met and so on and so forth. And we touched upon the designing approach, but I would like to shift gears a little bit towards setting the standards for the design. So as we know, with the emergence of AI, with rack power density increasing massively, there are a lot of these design standards are required, right? So I'd like to touch upon how the design standards are evolving to meet these requirements. So Mohie, if you want to start on that.
Actually, to address your answer, your question, I will address it from two different perspectives. Sure. From design perspective and from AI technology perspective. So from design perspective, so AI technology require far more power than the traditional servers. So it requires more efficient electrical system in the computer room. So by considering actually DC power distribution system in the computer room will eliminate multiple conversions from AC to DC and from DC to AC, which will enhance the efficiency of the electrical system in the computer room. And also it will save maybe around 10 to 15% in energy saving. Okay. So this will enhance and will empower the design from design perspective. From technology perspective, actually the AI tool can be actually a powerful tool to achieve more and you can say broader sustainability objectives by utilizing the AI tool as a sustainability accelerator. So this by adjusting the power and the cooling in a real time. So for instance, in AI tool can shift, for example, the server to maximum utilization as a server and put the ideal system in a low power state. So it will save significant energy in this one, and it will enhance the performance of the data center itself.
Okay. And you want to contribute to that?
Yes, agree that with AI load you can load the load the IT capacity much easier between the servers, the clusters and in the data center. So you can control it much better as in the traditional system. When we go to learning or so, you can say, hey, I have the temperatures right, I have the cheap power in the night, so I do more capacity or more AI learning in the night, and then during the day I reduce it a bit. So this gives you also the advantage that you don't need maybe 100% of the cooling solution for the peak of the year. You can say I go off an average value, and when you go with your temperatures about the average, then you reduce a bit your AI workload in the data center. This is a model where you do a peak overloading for some seconds that you get the demand, but your cooling solution will take it over the time. So I see there are also benefits in how you run your data center.
Sure.
And I agree with that, and you too, Mohamed. And we haven't addressed the cooling as a key critical success factor. Has any of you worked on a data center which is underground? So that's something that we're looking at, especially for the Middle East, where we're near the equator. So we're looking at average day temperatures in the summer at 48 degrees, and in the desert where the data centers are, I think you guys need to show this down, all right? So where the data centers are, we're looking at peak temperatures averaging 51 to 53 degrees. But underground, it's much cooler. The cost implications for obviously building underground is much higher. However, over a period of time, the amount of money that you'll spend on this level of cooling, which is a very critical factor for these kind of data centers to be able to provide this and absorb this kind of power, it does pay off over a period of 5 to 7 years. If the life cycle of a data center is 25 to 35 years, or 5 to 7 years, the amount of money that you'll spend building underground, a data center underground, it'll pay off in terms of the amount of money you'll have to spend actually cooling it above ground. So this is something that we've looked at for Abu Dhabi, and we're working with few semi-government companies in Abu Dhabi. I'm not allowed to share exactly where, but Kizad is an area in Abu Dhabi where we're specializing in data centers which will go underground. And the front players are always semi-government, but then behind it, there's other factors like governmental intelligence and data and so on, which we cannot share. But we've seen hyperscalers from Fortune 500 companies coming in and sharing their knowledge base and either operating that data center or participating in the design and build process.
I think the concept of building an underground data center sounds quite interesting. Obviously, things are in the POC stage, I believe, and needs to see like how it evolves. But yeah, that sounds interesting. Mohamed?
Okay, I think the underground data center will work for some region, in some areas, and other areas it will not work. Actually, as a part of design, you can say standard and the process, so it will come under the site selection in the data center. So maybe in some region it will work, and other region it will not work. Yes.
Soil testing will dictate actually.
Yes, exactly.
That leads us to an interesting question. So basically, right now we are talking about AI, where we know what kind of rack density that we are getting. But if we look even beyond, like what lies in the future, and we touched upon that, and probably the answer is there is no such thing. But I would still ask the question. What initiatives are being taken, or what can be done to basically be a little more future ready in terms of designing the data centers and so on and so forth? So I'll go to Alistair for that, and probably I know the answer, but yeah.
Yeah, I think obviously where we are today is at quite a challenging location. Obviously, if we look historically, back at the 2000s, we were talking at rack densities of 1-2 kilowatts per rack. If we go to 2010, we were probably at about 15, 20. 5 years ago, we're up to about 30 or so kilowatts. Today, we're starting to deploy up to 120 plus kilowatts. There's announcements that next year we'll be up to about double that, 250, 300 kilowatts. So the ramp of change that we're talking about is significant. But if we look at historically, we've always designed based upon what is needed at that time. It's very hard to project forward and say, yes, we will design a data center that's for a megawatt rack. And the challenge with there is capex. There's so much money you would need to invest more into that it'll be a waste of money basically, because you want to design it for the now. And the other challenge as well is for instance, rack. The actual rack itself will be different. We'll need a different busbar solution to serve it. We'll need different cooling solutions. Even the structure will be different. The weight of the rack is more. So you're going to have different load-bearing strengths for the slab. You're going to have stronger upgraded lifts. So what we're talking about now is we're designing for what is available now. So we design for what is coming. And what comes later on, yes, we will have to look at that more closely, but it might mean that we have to take a data center and say, for instance, you've got a 50 megawatt data center. It's still a 50 megawatt data center. You can't upgrade it. That's how much power you've got. That is what infrastructure is for. So where we have greater densities on the rack, maybe we have the newest, greatest chip from NVIDIA, but we don't max out the rack to 250 kilowatts per rack. Maybe we keep it at the design density that it is at the moment, so we can still take the advantages of the greater compute from the newer chips, but you don't maximize it to the level which you could do.
Just thinking out loud, could the modular and prefabricated construction or design approach that we are taking, could that help serve a purpose so that you don't invest all kind of capex on day one, but you keep upgrading the network and infrastructure?
The challenge you've got there is just looking at the infrastructure. So again, if you've got 50 megawatts coming into your site, or say 75 for a 50 megawatt IT, say, rough numbers, that is all you've got. So yes, you could look to densify your space later on down the line, but for the land that you've got, you'll have space. You'll have leftovers. So it is a challenge, because when you look at NVIDIA's deployment, they're talking about a yearly rhythm, which means that on a yearly basis they're looking to not necessarily release a new chip, but enhance where they are, or release a chip. I think every other year they're talking about it. So you've got this rhythm where there is a massive increase in capacity at each time, but from a construction's perspective, if you speak to us and say, look, we want to deploy, what time scale are you talking about it? 24 months is a reasonable figure. But at that point, there would be new chips out there.
Sure. That makes sense. Yeah.
Yeah, the thing is, maybe you have to look on a different perspective. You build a data center for 50 megawatt, it stays 50 megawatt because of the power, what is coming in. But the white space, you will have maybe instead of 40 racks, only 4 racks. And this will be the challenge. So when you look in the building, you must make a bit sure that you have corridors where you can install an additional bigger cooling pipe or a bigger bus bar to support then the 4 racks with the 50 megawatt. Then you can keep the building itself. It's only an empty building with a lot of space.
Sure. Makes sense.
And sorry, just to say that's what is actually happening. So with the pivot from cloud to AI, there has actually been a slight pivot on certain projects we're working on at the moment where they've actually pivoted back to cloud. So there's certain designs we've done where we've allowed, from a permitting perspective, and this is predominantly in Europe, to allow for a cloud compute solution, but while still having a design there so we can deploy AI. And that instance, yes, half your data hall is empty because they want to permit for the worst case scenario, but still allow for AI compute.
Sure. No, that makes sense. You want to add something?
Yes, big part of the white space in that case will be empty, but there is still 2 challenges. Not only the limitation of the power, but also you have the bus ducting, which is transferring the power to your white space. That need to be designed in a way to accommodate changing to a higher density, and also the cooling. Cooling might be fine for the white space overall, but if you look at it, if you are going to set your high density server racks in certain points, you might create a hotspot in other part of the white space. Okay. So yes, challenge is always there when it comes to designing a data center which will survive for the next 15, 20 years.
Sure, that makes sense. Sorry.
Just quickly to circle back, prefab and modular construction technology has been around for quite some time. I've been at it since 1999. So it's nothing new. But I like what Yousef used, the phrase that he used in the first part of his speech, that it's plug and play that allows us scalability. And the only limitations is the amount of space you have and the power supply. So now, Jan talked about power and Alistair did as well. So where I am really suffering as a developer and builder of data centers is that semi-governments are very shy to go into sustainable power grids. So the region we are at, we are so blessed that solar power and wind power is abundant. And the angle of the equator where we are at right now, it's almost perfectly situated to generate all of the power that we need from solar. And it's a myth. And I don't know if it's some sort of a politically designed scam, I'm not sure, but it's a myth that we don't have enough solar energy or the capacity to actually absorb them and then store them and then use them in a data center. Absolutely ridiculous, this theory. Alhamdulillah, we say that the amount of solar energy available in this region, we can actually supply power to maybe 100 times more data centers that already exist. And just circling back to our earlier point where I mentioned underground data centers. Underground data centers for military purposes have existed over the last 30 to 40 years that we know of. For commercial applications, underground data centers for government, for very secretive projects already exist. And the very reason that they're underground is to ensure that the redundancy for risk mitigation for any kind of risk, whether it's natural seismic activities or any kind of force majeure activities like a war, is completely mitigated by building underground. Now, Mohamed mentioned a very important point, which I did not talk about because I thought it would be obvious, that you can't build underground data centers everywhere. You can't, but the fact is, when we look at a feasibility for any project, infrastructure project, the first thing we do is a soil testing. And we're lucky today because of aerial survey and ground survey and the kind of satellite imagery that we can generate. It's very easy to map out a surface area of entire region like Saudi Arabia and understand exactly where your water tables are.
Sure.
Majority of the parts where the cities are built, especially like a country like UAE, so Abu Dhabi, Dubai, Sharjah, Ajman, Ras Al Khaimah, the water tables are within 5 meters from the surface. So financial feasibility doesn't make sense to build data centers underground because the dewatering cost of such a data center is tremendous and the risk mitigation is through the roof. Absolutely. And you can't have a data center be disconnected for whatever reason. It's not like a normal commercial building. However, if you go closer, just further away from the coast, you'll see that the water table reduces and the sediment is so perfect just for building data centers. But what you need is reinforcement underground with concrete steel, and that takes care of all your risk mitigation. But remember I mentioned that the cost implication is much higher than a conventional construction above ground. But if you look at the net present value of a data center and you look at 7 to 10 years and look at the present value today, it's much cheaper to do it underground than to do it above ground. And this, as a strategy, will be coming out very soon, and you'll have lots of papers on it. But it's not shared across the board as much as we'd like to.
Sure.
Can I ask one question? When you say underground, how deep? Because the earth gets, when you go deeper in, hotter again. So there must be a certain sweet spot for underground data center. It's more as you cover out from the environmental temperatures and the sun. This is what you mean as underground. So you can build a traditional above ground and cover it in sand.
So a very naive example, so we're in a hotel, and I'm not sure actually if they have underground basement car park. So if you look at the basement 1 compared to basement 2, the difference in the temperature, it depends on how you are actually managing the inflow and outflow of air and circulation inside. But the ground temperature doesn't shift as much. It's maximum 2 to 3 degrees, so it's not that much. Now, I don't know how far you have to go for the temperature to escalate, but most of the data centers that I have looked at that have been built underground, and one so far that I know about in UAE, it's within 5 meter range underground. So it's not a big drop from ground.
I think that's quite interesting part. In the interest of time, I'll just touch upon one very critical part that you mentioned, Nesar, about the funding. So I'll frame this question as an overall overarching thing, and funding could be one part of that. Basically, how the overall ecosystem to deploy or to develop these data centers, whether it's construction suppliers or vendors or design or funding, how is it all evolving in the region to meet the unprecedented demand that we have been seeing, right? So we can probably start with the funding, and then we can touch upon the other aspect of the ecosystem from the other panelists' perspective.
So thank you for that. It's a very critical point in the design development lifecycle of a data center. In fact, one of the first things we look at before even the design is conceived, we look at the financial feasibility of a data center, just like any other infrastructure projects. The fact is, cash is king. Yousef said that. If you don't have the funding, forget about building. You can't even do the design or the feasibility. So the funding is the first real criteria. So what we are seeing across the region, especially in the Middle East, so you have a lot of interest for data centers, obviously, from government and semi-government. So the funding is relatively easier in this part of the world. However, nobody wants to put down, I said 500 million US, Jan said 2 billion US. Nobody wants to put down that kind of cash on the table. Okay, so it's largely debt financing. Now, if you're getting into debt financing, then does it make sense to come in with a consortium? With the consortium approach, what will happen is maybe the debt financing will be leveraging something like 30 to 40% of the actual cost. The actual borrowing, and especially if it's semi-government or government, then the borrowing cost is very, very low. So then we're looking at another 30, 40% that are actual borrowed. Then you need somebody to come in to bridge finance. Now this bridge financing, although it takes some time to mature, is the first one to hit the bank. And you will have a lot of players lining up, especially if it's a semi-government data center, to bridge finance. And then we look at private data centers and what are the applications, and is there a way to monetize those data centers? Obviously, if it's a privatized data center, there is definitely a monetizing study done on it, and there's a model based on that. So then you'll have a lead tenant or a head tenant, and you look at a 10-year spread on how much that data center will generate in terms of income. And a bridge financing third party will come in with a structured financing approach, and they will actually fund the project, a certain percentage of the project. Now, certain models that have worked in the Middle East very well are PPP, so public-private partnerships. Joint ventures, of course, is something that is preferred in this region. And the third part is something that I haven't seen in GCC, but I have seen in, I suspect, Mohamed, you're from Egypt. So in Egypt, there are quite a few such models that have worked very well on joint venture basis, as well as BOT. So build, operate, and transfer, or build, operate, own, and then transfer. So this kind of financial models are very conduit to a data center construction project. Now, something that we have to keep in mind is, where do you build a data center? Today, even though my client may be from UAE, we don't have to build a data center in UAE. Our internet speed is at such a high end that you could have a data center in the middle of the desert, somewhere in the empty quarters or in Saudi Arabia, and we can have just as much bandwidth and the security as well, depending on the political friendliness. But the question is, what is the country rating of Saudi Arabia compared to, let's say, UAE? So you would have to, as a financier looking at the feasibility study, look at the country rating and see how easy it would be for you to borrow for debt financing and structure funding. And then you decide which country to build the data center. So this is a different kind of a vision that most people are not looking at. They're looking at things locally. We can build data center anywhere in the world, as long as three things are mitigated. So one, I already talked about, the politically, are you a friendly country or not? Okay. Second thing is that the country rating. Okay. The third thing is the availability of funds locally and the likeness of international funding players for that country. So this is how the funding structures are actually evolving in data centers.
Sure. So that's a fact about funding, but any other play from the construction vendor design perspective, how the overall ecosystem is evolving? Anybody
I guess one point for me, which we haven't touched upon in terms of an item that does need to be looked at, and I know there's been a lot of focus starting to move on, is simple things like training. Mm-hmm. So we talk about how the Middle East is growing. Saudi in particular has got massive ambitions to grow. As designers, it will take us 6 months to design a data center, support at construction stage. It can be less, depending what scale you're talking about and the rest. Construction, 18 months, 2 years, maybe a little less, a little bit more. Then somebody's got to run it. Mm-hmm. So all of these, for the scale that we're talking about, we need professionals who are going to come in and actually do all of that work. And from the scale that we're talking about 100 megawatts, at the moment, up to 1.9, just purely from Humane, and that doesn't include everyone else. Well, that's a huge uplift. So there's a whole element at the moment that we looked at in terms of talent. And I guess one of the advantages there is that Saudi can pull talent in from the other regions, but there's still a lot to be looked at and a lot of homegrown talent that needs to be.
Is it just about the designing part, or it includes
everything?
Every stage.
Every stage. If you think if we've only got 100 megawatts at the moment, that's a very small sliver of expertise.
Sure.
If we're going to go to round it off 2 gigawatts by 2030, you're talking 20 times more.
Absolutely.
You need so much more skilled people.
Anything else? Anybody else want to add, contribute? Mauladeen and Yousef.
Just on the talent part, so Saudi Arabia is around 150 megawatt now, and you're talking basically easily 3 giga 20 times, which basically means you need easily 10, 15 times of the skilled engineers. This include consultant, this include the vendors ecosystem, this include the contractors. It is a challenge. And frankly saying, most what we are seeing now in the ecosystem is whenever I'm going to recruit, I personally target individual and other consultant. They do the same. Training part, yes, we are training, but it's not speed enough to catch up with at least what's planned.
I think in Saudi Arabia, for the talents, there are special initiatives running now up to build here with Uptime and some other companies coming in and make academies to build up all the required workforce. But this will need years. When we talk about 2030, this is 3 years, 4 years ago, and it will be difficult, even when the university changed today, to give the demand and engineers and qualified people by 2030. This is a period of 3 years. When you're in Germany and do a normal apprenticeship, you need 3 years. For university, you need 4 to 5 years. So they have to recruit talent from other regions. And the other regions will not give it easy now, because in Europe and America, everywhere is the demand growing and they build.
Absolutely. So it's not just the region which is evolving into the data center demand, but the whole world is seeing such kind of demand. This is John Went.
Exactly. Like I'll give you, the US market is somewhere between 50 and 60% of the data center market globally.
Absolutely.
If you look at the region, I don't believe we hit the 10%. We're somewhere around the 5% of overall. So with everything happening here, comparing to the world, data center is basically data overall is the new gold of the world.
Absolutely.
And if you want to move to the 5th era, you need to be ready.
Absolutely. Yeah.
So actually, it depends also on the companies itself. Always you are recruiting some people from outside in your firm, but also some companies developing their stuff. You have the stuff already, so just training them, just develop them, then you will be able to have the you can say capable stuff to do this challenges.
Thank you very much for everybody's input. Do we have time for questions or no? Sorry. And I would like to thank all the panelists for their contribution to the discussion, and the organizers for arranging this discussion, and the lovely audience to hear us out. Thank you very much.